All right, we are live. We have Mike Faraday Research and Gerald WPG Enlightened for Truth joining us today.
Hello.
Good morning, my fellow Canadians, my fellow free energy Canadians. How do we do today? It's a good day. It's an APEC day. It's a free energy day.
An APEC day rocks.
Right? And it's a superconductive day, and that potentially this new, if we get this verification of room temperature superconductivity very simply produced, it opens the doors for all of the work and results that you lovely gentlemen have been getting, and that it could be everything is now that is inductive, that is endothermic, that is magnetic over unity, over efficiency and plasma. All of it is essentially potentially superconductivity.
Yeah, I would have to agree. Superconductivity is the, let's just say it's the next stage, if you know what I mean. And I think as Mike starts releasing more of it, I know he's got, because he's a very smart individual. So he's probably got some stuff kicking on the back burner like I do. I'm in the position where I'm going to start releasing it, and I'm showing everything. So I'm starting small, but we'll get there.
Yeah, I think, the superconductivity is definitely the next step, and it's just, a matter of time before, we crack that barrier, right? I think it's just a matter of material science and figuring it out. It's just, it's a matter of time. You know what? It's like anything else. The concept's there. It's been out there for well over 100 years. And material science has made a lot of progress, I would say, in the last 10 years, not alone 100. So, yeah, I think it's just, it's around the corner. And when we can achieve that, super efficiency systems are definitely possible. But
especially 3D printing aspects, right? And that's something that you've also been working on, Mike. And that, like, as soon as these little tiny nano circuit sort of superconductive like transistors and different capacitance things are able to be made, it's gonna, like, in 3D printed, essentially it's gonna revolutionize the world, right?
Well, I had some ideas about using 3D printing and mixing barium titanate in the PLA plastic and make printable piezoelectric transducers in any form you wish. So that would be interesting to actually see if anybody out there could actually pull that off. Because like piezo's, piezoelectric effect.
I like that, right? Because that can even then go into the geopolymer style building materials, and then 3D printed houses, and like
exactly
just get into
anything you make with a 3D printer could be piezoelectric. And apparently Tesla was working on, well, he was fascinated first most with quartz crystal, and he actually referred quartz crystal as a living entity. And I'm starting to dig some of that stuff up now. I never knew he was into the quartz and the piezoelectric effect. Apparently he did a lot of work behind closed doors with this stuff. So I've been doing a little bit of digging on what he was actually after and what he was trying to accomplish. But he did refer to quartz crystal as actually a living entity, like you or me.
I love that you say that. Sorry to cut you off, Gerald. I'll let you talk. Just the alchemy and the alchemists, they all state that the metals, the elements, the lower matter, and then the vegetables, the plants, and then the animals, that it's all living conscious matter, just in different states, and that these crystals are essentially live, and so are all matter and energy. Yeah,
even gold. A few people have stated along, my research that gold is actually a living entity as well. So it's got to be some kind of connection.
It is written that, you know, ashes to ashes, dust to dust. So as everything collects, you know, it compacts, turns into different minerals, and who knows, like you said, maybe it is a form of life, so to speak, or a compressed piezoelectric crystal from a form of life.
Yeah, exactly. And that's it. That's what Tesla was working on. He knew this a long time ago. And apparently he was totally fascinated with the quartz crystal. So, yeah.
I haven't read a lot of his crystal work and notes, but I've heard whispers of him working on it, and that was like his passion that he didn't really bring out a lot of.
No, a lot of that stuff was hidden. And I think a lot of that was some of the notes that were taken after he passed away at the New Yorker hotel. I think a lot of those notes and references on quartz crystals was all confiscated.
Well, I bet you it was.
Yeah, it's certainly possible. If you follow back from Otis T. Carr, and he states that he had access to Nikola Tesla. I don't know, was student, I believe it was. I'm not sure. Don't quote me on that.
Carr, no, he worked at the New Yorker hotel as he used to clean the rooms and stuff. And then he bumped into Tesla, and they became good friends. And he started learning, you know, what he was up to. And, you know, he was a science student at that time, and that's how they got together. They met at the New Yorker hotel.
That's interesting, because isn't he involved with that story of the apparent UFO that they created that moved?
Oh yeah.
And they used their minds to move it, and it had a big crystal in the center of it, and very interesting story.
Yep. See the connections now?
Definitely.
Always connecting more and more dots. And I have a few dots actually to collect for. While I have both of you, actually, let us instead of playing the this excellent LK99 superconductor, we will play it here. But first, we'll play a bit of this amazing video just released and done by Jillian Rachel on ElectroCulture, but she goes deep into the science here of the history of it. A couple points that I think both of you would appreciate more to hear.
Plants and people are sensitive to electricity and magnetism. Improved plant growth, quality, and increased yields are a few of the noticeable beneficial effects in plants. The technology can also be used to protect plants from pests and diseases. Electric and magnetic effects on people are very similar, as demonstrated by the dedicated work and research of Georges Lakhovsky with copper coil oscillators in the 1920s.
So Georges Lakhovsky. Have either of you heard of him before? Mike, you're muted, brother.
Yeah, I haven't really heard of him, no.
Okay, so
I have. He's actually go ahead.
Right, so I'm just gonna let it play here because this next part is absolutely crucial in all of the work that we're doing and the field interactions and another suppressed scientist.
Yeah, his work was directly connected to Tesla, so he's a very interesting person to follow.
Really? So you learn something new every day. And right here, his work with copper coil oscillators in the 1920s. So that would be Tesla right there.
You're talking about Otis Carr?
George Lakhovsky. Yeah, he had a healing device with copper coil oscillators.
And, you know what? I've heard of him. The name does ring a bell. I don't really know. I know more about Otis Carr than I do him.
Yeah, there's a Tesla connection to George Lakhovsky. I'm not exactly sure what it is. I don't know if he worked with Tesla, but
these copper coils, they're almost like they're like those are very fascinating bifilar coils right there. They're like
Aren't there superconducting antennas that have been built on that very same configuration?
I believe so. All right, so
Interesting.
here, this part right here is crucial. It's a little low in volume, but it's just great find
Oh,
by
Gerald,
Rachel and Rachel.
sorry to jump in. Gerald, did you get that link I sent you on Vinny St. Vincent? With
Yes.
the
Oh yeah, I was gonna play
Thank you
those
very
videos
much.
as well.
I've
yeah,
watched
did
that
you see
about
that?
8 times, and I'm gonna watch it probably another 8 more. So yeah, I've seen it.
Minkowski believed that each of our cells was a minute resonant circuit, and when these circuits were oscillating correctly, we or any living thing were considered healthy. When an outside source causes our cells to oscillate at a different rate, then disease sets in. In his book, The Secret of Life, originally published in French in 1925, Minkowski wrote, "What is life? It is the dynamic equilibrium of all cells, the harmony of multiple radiations which react upon one another. What is disease? It is the oscillatory disequilibrium of cells, originating from eternal causes. It is, more especially, the struggle between microbic radiation and cellular radiation." Minkowski believed it was these radiations that kept our bodies oscillating correctly, but too much of distorted radiation would cause them to oscillate incorrectly. Setting out to prove his theories, Minkowski felt that he could generate a practical application to enable the adversely affected cells to regain their full vitality by reinstating their proper oscillatory rate through a dielectric element such as copper. What Minkowski discovered was truly amazing. He discovered that using copper coils protected our cells from various forms of disease through an ability to generate a healthy electromagnetic field for our cells to continue oscillating at their resonant frequency. Georges Minkowski's research, where he demonstrated the comparison of a living cell with that of an electronic circuit of an antenna, inspired him to devise a theory of a living cell as an electronic circuit of high frequencies and electrical oscillations. This led him to publish his first book, The Secret of Life, originally published in French as Le Secret de la Vie, Paris, Gauthier Villars, in 1929. His focus turned then to the development of electromagnetic systems that can heal plants. Minkowski coils are little antennas made of copper, oriented in a certain way with north at around 32 degrees, in alignment with the tilt of the Earth's rotation.
So I gotta pause it right here in several major aspects of one, he turned his research to developing electroculture, to the north-south alignment of these copper coils, which is a key part to what I've been seeing on lots of people's actual electroculture results with the coils, that you have to wind them south one if you're in the northern hemisphere, and north if you're in the southern hemisphere, and place them accordingly next to the plants, vice versa, depending on what hemisphere you're in. And that it correlates to this, but that she was stating his research on the biofields of the resonant it's the resonant frequency, and didn't she say, or is it about to come up, where by giving alternate resistance, capacitance, and a little bit extra charge to the cells, the human cells and the plant cells, could get them into perfect homeostasis and health?
I've been forming a theory about electroculture and how it works. Like you said, if you're in the north, you wind the coil to the south, and if you're in the south, you wind the coil to the north. Completing that bar magnet, you're bringing that alternative energy. Like if you're in the north, you're bringing that southern energy into the plant, completing that bar magnet type system and allowing that 0 point, if you want to call it, or the null zone, to allow that energy to flow into the plant. It's just a theory, but I'm working on it.
Oh no, it's your theory is parallel to the theory, and it's all just the observation of how nature works. And the electromagnetic flows of the energy fields of the universe, essentially, and life simultaneously.
Now, if you're, say, south of the equator, is it going to change? Do you have to reverse it?
Yes, exactly. You have to reverse it 100%. You got it.
Yeah, it's like you got to complete the circuit. Does that make sense?
Oh, yeah. Absolutely. All right, I'll play I think she explains it a little bit more in depth here.
These antennas can be used for individual plants or trees to heal them from disease or
And
to
you can
help
hear
them
the sound,
grow.
right?
Yep.
Yep, I
What
can hear it.
Minkowski discovered was simply amazing. He postulated that all living cells, people, plants, bacteria, parasites, etc., hold certain attributes which are generally associated with electricity. These attributes include resistance.
All right, so I had to pause it right here, and this is the spot. This is the very important spot right here.
Capacitance, and inductance. When configured properly, sustained by a small, steady supply of outside energy at the right frequency, these three electrical properties will cause recurrent generation, or oscillation of high-frequency sine waves. This process is commonly known as resonance. Perhaps it could be simplified comparing it with a child swinging on a playground swing. As long as a parent or guardian pushes the swing, when configured properly, sustained by a small, steady.
Okay, one more time. Let's listen to this. And that resistance, capacitance, and inductance are the three factors that equal resonance, which is complete energy. It's a 369 thing I've been working on forever that connects light and magnetism and sound and vibration and all of it.
You're absolutely right. Like,
right.
if you can't hear it on the videos that I put out, I just got my sound meter and I've ordered an infrared camera. So I'm going to set up all my meters around my system in the next demonstration, and there'll be like an EM meter. There's going to be infrared camera. There'll be a high-speed camera if I can borrow it. There's going to be your input watt meter, your output watt meter. I'm going to have it all so that you can see exactly what's going on with the system.
Yeah, see, the thing is that I'm noticing, especially with the stuff that we're working on, it gets more difficult to take measurements because we're dealing with energies that our regular meters weren't really, I guess, designed to measure, right?
Have you seen my latest video, Mike?
Yeah, I just seen that. Yes.
So I think having a meter on the input gives a general idea, as long as we're showing more output than in, so to speak.
Yeah.
Like I'm doing work with the excess, and my wattage is going down. So I don't know how to explain that other than 0
I've seen
point.
it so many
correct.
times. Too.
Okay. So, speaking of which, I did a test last night. What I did, I took sorry, I'm out of breath here. I just climbed a flight of stairs.
A flight of stairs. I climbed a freaking mountain yesterday, and you're
it's more. It's actually more than a flight of stairs. The side of a mountain. I'm at a beach right now, so you have to climb down the escarpment to get to the beach area. Yeah, I'm right at the base of the Niagara escarpment. Actually, hold on.
Oh, you're at the Niagara. You're at Niagara? Oh, my goodness.
Well, I'm in my hometown because Niagara escarpment ends where I live.
You got to drive to the waterfall and old Tesla site, good sir.
Yeah, I'll have to do that.
Take the kids there before the weekend is done, please.
I'll show you the escarpment.
Oh, and
So-
definitely turn her sideways if you
Oh,
can. There we go. Awesome.
Okay, so this is right at the base, at the end, at the basically north end of the Niagara Escarpment.
Oh, I know what you're saying. I know
It,
where
it goes all the way from Niagara Falls to my hometown where I live.
Nice.
Yeah. So this is called Kelso
So
Conservation Area.
story I don't understand about this is that supposedly before they somehow stopped the Niagara River and Falls and then like built the new canal and waterfall, it was like eating like 6 feet of the water, like away of the entire bank a year or something, and it was like roaring so loud that like you could hear it for like miles upon miles, and it was like way much like exponentially more water coming through it. And then
Yeah, didn't they shut it off? and
yeah,
then
they
fix
completely
it?
shut it off for a while supposedly, and like built a new canal and like all sorts of crazy shit that makes no sense, and it's very interesting.
Yeah,
So
Niagara's
anyways,
interesting.
just to kind of describe this area where I'm at. So this is, I don't know if you can see right up in the left area, there's actually a cliff. It's about, I would say, at least 300 meters straight down. It's like basically just a drop.
What's
Yeah,
on the
yeah,
So that's the end of the escarpment. right?
Right, so that's what
Okay.
used to be eroding at 6 feet a year or 6 feet a month or something
Well,
insane.
yeah, as far as I understand, it's separated and dropped about 60 million years ago. And that's the result of the drop.
Yes,
From-
yes. But I'm talking about the actual erosion level on the waterfall, that it was like eroding away supposedly
Yeah.
each year, and that like the amount
So,
of water that was coming through was like exponentially more, and like it was just nuts. And
this area here is like built as like a provincial park. There's also skiing here. They have ski lessons in the wintertime. They have a small hill here. It's called Kelso Conservation Area.
that's
You can
awesome.
look it up. So I literally live like 10 minutes away from here. So,
Heck yeah.
so,
What are you doing?
so going back to what I was saying about the motor, what I did the other day. So I took a small capacitor bank, and what I did was I put about started around. Well, I started off at 12 volts. I let the motor wind down, so it got down to about less than, yeah, it was about 0.5 volts. Okay, the motor's still going at a pretty good clip. Then what happened was it went down to 0.2 volts. The motor stopped running, bounced back and forth, and then started spinning in the opposite direction, then speeded up and ran for another 8 minutes with
What?
no power. There was no
Really?
power. There was, I repeat, there was no power
outta
left in the capacitor. It was
That's
completely
interesting.
discharged.
That
And
sounds
it
like you
reversed
you
from the
tapped
other
it,
way.
you opened a hole or of
Yep,
some
you know
sort.
why? My
And
coil
there's the
cooled down.
potential coil on the opposite side. That's so
Yeah,
insane.
so
Please
as a
explain this
result-
one more time.
as a result, my coil cooled down to by 8.5 degrees cooler than ambient.
That right there's some cold electricity, right? Some
Yep.
endothermic inductive.
8.5 difference. It went
That's
down.
awesome.
And I did it over and over and over again. I got the same effect. So what I was thinking of doing, just as a little experiment, probably in the next week or so, I'm going to purchase a little bit of dry ice. And I'm going to set it right beside the coil and super cool the coil down and see if I can extend that run time from 8 minutes to longer. So the motor naturally runs counterclockwise.
Maybe.
What's that?
To indefinitely running and levitating, maybe.
Well, the indication really got me suspicious when it started in the opposite direction on its own power and then accelerated. Not just start to
That's what
speed,
really
it
gets
accelerated.
so fascinating, right? It's like it's almost this like it's like it is a twisted unwind, like
Right,
reverse,
kind of like a round spring. Yeah,
right? Like yeah, like a spring back, but like in this meta, like
it
man, like
sprang back, but it
magnetic
accelerated.
field that extends
Something like
outside of the matter itself somehow. Like that's like just fascinating as fuck.
something like that happened to Stan Meyer with his EPG when he was
Yeah.
running it and pulsing it. The rotation
Also,
for the
John
particles that
Searle,
were
I
running
believe,
stopped,
similar
went
to
the other
two.
way, and created a sound like breaking the sound barrier. Sorry, it's an
Really?
interesting story. Russ Grease, he speaks of it better than I do.
Yeah. So, anyways, I've been able to repeat the experiment over and over and over again, so I know it's not just a fluke. So,
Right.
You got to get it on video, Mike.
Science.
yeah. So my
You
next
got to get
step,
an infrared. You got to get an infrared camera to get your coils, take pictures of them. That'd be awesome.
yeah, because like, you know, when it started cooling down like that, and then under its own power, it stopped. It bounced back and forth, left and right, or clockwise and counterclockwise. Originally, it started.
Say it should just stop, but instead
No, it didn't. It
went
bounced.
the opposite way, inverse, and accelerates and runs.
It
for another
accelerated under its own power. I didn't have to touch anything. It did it on its own. So when it started going, like normally I run the motor in counterclockwise. And then when it stopped, it bounced back and forth, left and right, and then started spinning clockwise and then accelerated with 0.2 volts left in the capacitor. 0.2 volts, nothing. Like literally nothing in the capacitor.
That's awesome.
And then the capacitance of the capacitor bank I had was equivalent to a AAA battery. So tell me something's not going on there. Something
just
anomalous.
a wee bit magical.
Yeah, I think what I did was I rebounded off 0 point, and it gave me that rebound effect. Because if there's no power in the capacitor, where is it getting this energy from? Where is it coming from? It's got to be coming from somewhere.
It's like dark
Can't be coming from
or dark matter, according to their like official. You're actually tapping quote unquote dark or quantum energy, the 0 point. You know, you're pulling it out of the, but it's cold energy. It's just, you know, it's the cold.
Oh yeah, it's cold, all right. Yeah,
endothermic side of things.
As soon as your conductor starts cooling off, that's an indication that you've hit the 0 point and you got negative flux rebound, right? So that's how I
flux rebound. That's exactly what it should be called. As you know.
Now this effect will not happen with a battery. It will only happen with a capacitor bank running it.
Right.
That's interesting.
There's that negative flow of of batteries too, right? Like that negative negative electricity in certain types of batteries, but other types can't handle it and shit.
Well, I think what it is the separation between the plates and the dielectric in the capacitor bank might have something to do why that negative flux is being drawn into that capacitor bank. So maybe it's not even coming in from the coil, it's coming in from the capacitor. Maybe the capacitor is what's pulling in the negative flux from the rebound.
From the dielectric field bouncing back and forth.
Exactly.
Yeah.
You got it. You got it. That's what I figured.
That's interesting. You got to get that on video and take some, like I said, either infrared camera shots or maybe some.
I wish I had one.
Laser temperature gauge, maybe. I don't know.
Well, I did the laser temperature gauge. It was an 8-degree drop.
Oh, that's nice.
8 degrees from ambient. So it was my ambient room temperature was 22, and it went down 8 degrees.
That's amazing.
And it was not only, it was actually physically noticeable. I put my hand on the coil, I could feel the coolness.
Electromagnetic cooling, that's freaking awesome.
Now, what I want to try to do is simulate the same thing I just did with the Renegade. So this is with my small model, the baby Renegade. So if I could do it, I got a bigger capacitor bank. It's 500 farad, 16 volt. If I retrofit that onto the Renegade and repeat the same experiment and see if I get it.
When you use your super caps, do you use a balancing board on them, or do you just, are they straight up?
Well, the small one, the small bank doesn't have a balancing board, but the larger one that I have, that's 500 farad, does have a balancing board.
Makes sense. I don't, my balancing board's fried, so I don't know. I just haven't played with them lately.
All you have to do is just charge them slowly. If you charge them slowly, they'll charge evenly. But if you try to hammer like 10 amps into it in one shot, you could do damage. You'll get thermal damage.
Yeah, that's when you need a balancing board, eh? If you're gonna dump major in it.
Yeah, like the small one, I never really go past 1.5 amps when I'm charging it up.
Makes sense.
It's small. It's a tiny cap bank. It's 90 farad, 12 volts. It will run my motor for 30 minutes.
That ain't that small, but I get your point, though. It's
Yeah.
smaller than 500.
And then to boot, it stops and goes in clockwise and accelerates with 0.2 volts left in the capacitor bank. So where it should be bottoming out, it seems like it's pulling energy into the capacitor bank.
Yeah, that's very interesting.
Like that's some game-changing stuff right there.
Now, see, back in the day when I first did that experiment and I got that effect, obviously I did not have the foggiest idea what the hell was going on. And at that time, I didn't know about the piezos yet. So now I got the piezo hooked up. I got a barium titanate hooked up to the baby Renegade. And I did the effect and it was even greater because of the piezo.
I know what you mean. When I first started building coils, I was just using function generators and pulsing them. I wasn't using them with loads and then running it through them. But now I've done something different with it.
It's
and
crazy.
I'm getting so much more
fascinating? Sorry to interrupt, but isn't it fascinating? The higher the load you put on some of these like dynamic circuit systems that you make, and you loop them, the more efficient it becomes, and like the cooler it becomes, and like the more power, and it's just
absolutely. Don't play with the load.
What it should.
Well, you know what? I think there's a correlation with that because it's like an elastic band. When you pull the elastic band, it's kind of like you're pulling a load, right? So there's going to be a rebound. So it's going to want to pull back. And I think that's what we're doing with the flux energy. We're pulling it, releasing it, and letting itself pull itself back into its fixed space. And I think that's why I'm getting that effect in the capacitor.
That could be.
So,
Mike does. What's your email, brother? And I will send you the link right now, good sir. And then also, guys, sorry, I will be back in 5 minutes. I just have to check on the wifey and make sure she's good. And I will be back momentarily. Should I play your video, Mr. Mike, or you guys, or I meant...
Yeah, I got to bounce here for a while because obviously I'm at the beach.
At the park?
So, yeah, I'll definitely, if you guys are going to do a stream tonight, I'll be available tonight. Yeah.
Absolutely.
Going to relative's place tonight, but I can do a live stream from there too.
Okay.
Oh, that's awesome.
Sounds good. And I'm going to email Mike Does here so he can hop on, as he has been crucial. A lot of great advice and
Yeah, I was
Or
going to send Harold that information on my experiment the other night, but I figure at some point I'd go live stream with him and tell him in person. So
Yeah, that's
right?
great, Mike.
How
You're
we
doing
do.
awesome. Keep it up. Because now you're
yeah,
at the point.
I really want to try it with the Renegade on a bigger scale because the coil I'm using in the Renegade is over 2 pounds. So how much can I drop in, right? That's the question.
If you up the machine again, you'll have to up your capacitance. It's all about balance, right? It's the same.
Yeah, so I'll probably use that 16 volt 500 farad capacitor bank for that test.
That
So
makes sense.
that'll be easy to do. So yeah, it's also good. I got the thermometer as well, so I can take temperature readings of the coil.
Awesome. We got to somehow get you an infrared camera, Mike.
What's that?
We got to somehow get you an infrared camera.
Yeah, that would be kind of neat.
Maybe
But the other thing too, what I'm going to do is I'm going to get a hold of some dry ice. I think that's going to be the next step. I want to see if I could super cool the coil down and
Yes,
increase the
please.
effect.
And please live stream it with us on our channels. You should be live streaming this on your channel. Well, maybe tonight, I guess, when we sit down and do it, because you're at the park right now. I just shared your channel, Mr. Mike, in the live chat. And should I, before you take off here, play your latest video of testing?
Yeah, go ahead. Yeah. Oh, that one was with the capacitor plate thing that T-Von sent me.
Hey everyone, it's Mike from Faraday Research. It is
Guys, I'm going to take off here. I'll talk to you soon, all right?
Wednesday
Sounds good,
evening.
Mike. Much love, brother.
Absolutely.
I'm doing a test here.
All right, Ben. Take care. Have a good one.
You too.
Orgonite capacitor slash diode slash piezoelectric inductor. So I've been doing a lot of testing with this. I have it hooked up to my pulse motor, the baby Renegade, and I got it hooked up to the transducer, and then from the transducer goes directly into these two terminals of the box. And it's a 4-layer box. They're all isolated, so all the plates inside are not touching each other, and it's surrounded by the shugnite, copper, and a few other elements in there. That makes up the basically a dielectric is what I'm coming to the conclusion. It's some form of dielectric effect, which that material is made to be like a dielectric to absorb electromagnetic frequencies and basically remove the bad RF. So let's fire it up, and I want to show you what's going on here. Get the baby Renegade going here. We'll get it fired up. All right. So I got to fire it up. So these two terminals is what's coming from the transducer into here. These two are going to my leads of my meter. And I got one extra wire as a negative going back to the battery. So I have a ground source. I could ground it to myself or to the actual ground itself. But for the test, I'm just grounding it back to the battery. Okay. Now, I'm going to turn it on. I have it set on the AC settings. And as you can see, it's putting out about 6 volts AC, which translate to about 3 volts DC. Now, it's showing me a couple of things here. Actually, before we get into that, if you haven't seen...
All right, before we get into that, you can watch it on Mike's channel because we're running out of time. So now I am going to share Gerald's most recent video, 4 minutes of it, and then we're going to end this stream off with the half-hour Tim Ventura, Sean, I believe it is.
Yeah, because Apex at 2, eh?
Yeah, exactly, because APEC is starting in 50 minutes time. Thus, I have to, keep the schedule tight.
Of course, do your job, man.
Exactly.
Same setup as yesterday, except I included a watt meter. And I'm going to show you the wall plug one more time. This is a universal wall plug, 1.5 volt, switchable to 12 volt. It's a 300 milliamp wall plug. I'll try and line this up. There it is. Class 2 300 MA. That's the max you can pull out of this. I had to glue a new fan blade onto the fan because I broke the other one yesterday in a demo for a friend. Anyway, so it goes from the wall plug to the watt meter, from the watt meter to the transistor, which is pulsed by the function generator, which powers the DC fan motor. And on the return from the motor, it goes through the vortex coil back to the wall plug. So I'm using the power on the return from the fan motor. That light beam that I'm picking up there is from a grow beam. There's 4 panels. They're 94 volts, 1 amp to light 1 panel. And I'm going to attempt to do it on 300 milliamps. I'm going to put that ferrite core in the center of the vortex coil and see what I can do about powering that up and how much wattage it draws from the watt meter. Now, that coil is specifically designed to concentrate the field in the center of the coil itself. So that definitely helps. But let's continue and see. Plug it in. The function generator isn't on, so as you can see, the power's on. There's the watt meter. I'm just messing with the lights here a little bit to see what works better, and that seems to work better. All right, so I'm going to turn on the function generator, which is pulsed by 2000 hertz, 10 volt pulse square wave. And as you can see, I'm pulling anywhere between 1.9 and 2.1 watts to run that little fan. Now, when I put this in the center, the wattage should go up. Now, that light beam isn't at full. It's about 60%. But my wattage went down. Again, can anyone explain that to me? I'm running at 1.7 watts. We'll pull it out, and you could see the wattage draw go up on just the fan use from 1.9 to 2.1, sometimes 2.2. Putting it back into the center of the coil, and our wattage draw goes down to 1.7 and 1.8. Shut it off just to show you it goes back to 0. And its draws at 1.7 to 1.8 while the coil's running. When I pull that light beam out, it goes up. So if anyone could explain that to me, that would be great. Otherwise, this should be peer-reviewed for possible superconductivity. This does apply to many appliances. I've done many tests. And this little demonstration here is a continuation of yesterday, just to show on the watt meter what my draw is from the wall as I'm running this. The next demonstration will be a bigger coil and a larger load. I hope you all have a great day.
All right. Thank you for uploading that today, Mike. That was, or Gerald, I should say. That was awesome. And another Mike, thank you for joining us. It's the first time I think we've had you on.
Yes, sir.
Mike.
Hello, Mike.
Hey, how's it going, everyone? Been watching
Good,
both
brother.
your channels, by the way, Mike.
Mike does, right?
The other Mike He left already?
Yeah.
Yeah.
Yes.
And Gerald.
Faraday Research
Gerald.
Mike has left,
Yep.
but we got Gerald with us.
I've been
And
watching your channel too, Gerald. Nice work, by the way.
Awesome. Thank you.
right, and Mike, I've been fascinated by all of your inputs, and you've done a fair amount of your own videos and stuff you're working on too, right? On your channel.
So I was watching Mike's videos on the atom motor and what he's been doing with that. And I guess that's what he was talking about just now, right? The same motor?
Yeah, he was talking about the miniature version of it.
Right, and he was getting experience of it running without the source connected. So he might be capturing the flyback from the inductor somehow.
That's a possibility, definitely. But because it's spun up, I don't know if he's catching the flyback. Maybe that he's catching the flyback
On the off cycle, he must
be. Yeah, I don't know. It's an interesting.
His capacitor must be. He must have a diode reversed into the capacitor.
He's got an interesting circuit. You would have to go over it with him, or go back to his original videos and he explains it. That piezoelectric that he's got in the loop is pretty neat.
That might have something to do with it too.
It's fascinating. The more you add into the circuits, and like the more dynamic they get, and you can get these different amplifying effects, like on exponential levels, when you just tweak certain resonances and certain frequencies of specific pieces that you add into them. And
it's all about balance. Like
right?
I catch the flyback, and I also use the skin effect to multiply what's coming out, and I also use kind of like it almost acts like a buck booster. So I'm upping my voltage as well, right? So what I've tried to do is take every little anomaly, or whatever you want to call it, that most electrical engineers try and get rid of, and I'm trying to use them to multiply what it is that I'm doing.
Yeah, they try to get rid of it. So they call it surge suppressors.
Yeah, but I want that surge, and I want to be able to use it in order to make the system more efficient.
Have you, Gerald, have you replicated the Bedini pulse motor?
Oh, yeah. Yeah. Bendini, actually, I've been watching him. I even got to talk to him a couple times. So, yeah, he's kind of one of the first guys that got me all into this. Him and Russ Grease.
You know what's funny about that schematic is, I'm an electrical engineer. I graduated IDT. I have, education in this stuff, but I've never understood what he was talking about regarding the reverse flyback voltage. In the whole process of me replicating it and getting it running, I still did not understand that, right? And then after I got it running and some months of building a few of them, I still didn't understand it. What is the reverse flyback voltage? And so basically, when you charge up an inductor and you remove the charge, and it loses its charge completely to zero. At the 0 point where the inductor completely loses its charge, it gets a surge coming into it from the environment, and that can and that in turn flips the polarity of the inductor. So if you had two wires on the two ends of this inductor, you charge it, on the left end with a plus and the right end with a minus. By the time it loses its charge and the flyback comes in, the left hand becomes the minus and the right hand becomes the positive. It flips the poles on the two ends of the wire. So if you have a diode on the on the reverse positive end of the inductor, when it does flip, you can dump that energy into wherever you want. And I think that's what's going on. If you have a capacitor hooked up somewhere, capacitors are very capable of capturing reverse flyback voltage.
It's actually funny you say that, because that's part of how my bifilar coil systems work. I have on my secondary, I have a diode and a 1 nanofarad 3 kilovolt capacitor. So when I'm pulsing, it's filling the inductor, filling the capacitor, and when I'm not pulsing, that capacitor is running that back EMF back through the inductor, creating or reinforcing the magnetic field, right? So I'm getting it twice on one pulse.
Which is this again? Which setup is this again?
The setup that you've seen in the video, actually, most of my.
Well, you've got a lot of things. You got a lot of things going on, different things. So I'm not sure which one.
That's true. That's true. But on the coil itself, on the secondary, I'm using just a capacitor and a diode. But it's like reverse, right?
To capture the flyback.
To capture the flyback, to actually send it back into the coil itself.
Oh, the same coil that you're right. Okay.
Yeah, because my bifilar capacitors are not like other people's coils are not like other people's bifilar coils. They're separated differently. They act more like capacitor plates than they do an inductor. I use 7 different instabilities in order to make the whole system stable. And if you don't add one of those components, it doesn't work the way you see it work now.
So Gerald, what we got here on the screen here, this is a circuit here that's based off.
Should I replay it?
Is
with
this yours, Mike?
Volume, Mike, or do you want to just describe it, or should I just
is this your circuit?
I'll describe it right now. Yeah, I in the process of replicating the Bedini pulse motor, when I got done with it, something hit me. I understood something, but I didn't quite understand it. I just caught on to something, without still at that point not knowing what the reverse flyback voltage is. I caught on to it somehow.
Yep.
Visually through the circuit. I still didn't understand what it was, or that the inductor would reverse its polarity until later. So until after I created this circuit is when I actually understand that the inductor reverses polarity when the field collapses, which sounds ridiculous, but that's the case. That's the case. So
I didn't mean to cut you off there. The minute I seen this circuit, I literally drew it out because I know that this works.
Yeah, right. You could see it. If you understand how to capture the flyback with that HV diode, that high voltage diode there, you understand everything and you get it, and it makes perfect sense. But most people will not get this because they don't understand. They don't understand that the coil flips its polarity, and they wouldn't understand why that diode is facing the other way, which was the case for me for the longest time. And even until after I came up with this diagram, it was after the diagram was finally drawn out that I understand that the inductor reverses its polarity, which once again sounds ridiculous, but that was the case for me.
So
but it turned out to be work. I'm familiar with switches. I'm an electrician by trade, 30 plus years. I've worked with double pole, double throw relays. I understand all this complicated switching stuff in other avenues. So somehow this was able to come out,
Are you an engineer or just an electrician?
Yeah, I mean, I've engineered houses in my head and wired them up,
And you're building and engineering these. I'd argue that both of you are very qualified electrical engineers.
It's all about switches, really.
Autodidactic and self-taught.
Well, I was gonna say your education actually, when it comes to capturing the flyback and getting into this sort of realm of engineering, it stops you from looking at this because you're told, you're taught that's impossible.
I realized that too. I self-realized that I wasn't able to see it for that very reason.
Well, I applaud you, because having an education and still figuring it out.
You would never stop and say, hey,
that's why we actually need you, Mike. So much.
Awesome.
You're the bridge into so many electricians that I know that will be able to be like, here it is.
And maybe I'm incorrect about those batteries acting like a diode, as I drew that diode in there just to show that batteries essentially can be a diode.
No, that's correct.
Is it correct?
My first Bendini motor, I charged a battery, and I had pulse charged it for, I don't know, I did experiments with it for about a month, charging it, and then I took it out of the loop and I just started using it, and that thing was so hard to kill, it blew
Yeah,
my
right.
mind.
Exactly. I would concur with you on that. I had the same experience. Did exactly what you did with the Bedini. You let it charge up, to you got the run battery and the charge battery. So I'd be draining the run battery, from 12.5 volts and pulling up a charging battery from 11 volts back up to 12.5. And you see the run battery drops down to the same voltage that the charge battery started with. And at that point, you're like, and the whole time the wheel's spinning, you start to figure it out,
It's amazing. I love how Bendini did all that. It blows my mind.
He really opened the door.
Yep.
He really opened the door for at least me, and I'm sure a lot of others, on this reverse flyback concept of an inductor, which is key to understanding when you're having anomalies. If you want to, you call it an anomaly, but it's not. It's
a voltage.
It's not magic.
No,
it's only magic because you don't understand the reverse flyback voltage. If you did, you'd be able to build motors that spin, at their own force perpetually. As long as you don't create too much drag on that, it'll keep spinning, and you put a coil next to that. As long as it's spaced correctly, you won't stop the wheel. It'll keep going, and your coil will keep picking up.
So sorry. I have an idea for this, where as it's spinning and it's almost spinning itself perpetually, you know how when you pull energy out, it loses its torque and sometimes drops its spin.
Yeah, you got too much lens. You got to back off with your stator and gap it some more. Don't pull too much.
You get it. I don't even have to say no more.
In fact, anyone who can create an iron partnered with a magnet rotor and get it to just spin off the pull force of the magnet to the iron, and as long as you don't drag more than what the pull force is on your spin, then you can easily space your coil far enough so it doesn't break the system more than it can offer. And what the pull force of that magnet to the iron is let's say it's 10 pounds. If you put a coil that has 11 pounds of braking force, well, then you're going to stop the motion. So you put a coil that has 9 pounds of braking force. That's the concept.
It's all about balance.
And your wheel will slow down, but it won't stop.
Talking about, and it's so key. And there's actually a couple of tricks or like suppressed sciences of like how you wire the two positive negative coming out of the coil and through the
Bernie, you can see it better if you go forward in the video. I erased one half of the circuit so you could see how it go to the middle. Right there, forward, right there. You see how I digitally erased half the circuit so one can see how it's a basic Bedini circuit times 2 in 1. And I've gone over this multiple times to look for possible shorts, and I'm not able to find it. As long as the switching is done the way it's shown, switch A being closed while switch B is open, and vice versa, you won't have any shorts unless both switches are closed at the same time. Then you'll have a short.
So you can do this with solid state relays, essentially.
Yeah, this could be solid state, and the inductor. Okay, if you look at where the HV diode is pointing towards the positive of the battery A.
Yep.
Okay, now go to battery B. See, battery B is the one charging up this coil, giving it plus and minus. And you look at the plus on battery B, see where it's touching the coil?
Yep.
Okay, that's going to be the positive terminal of that coil. And when when that switch A is now open and that coil loses its charge, where you see battery B touching the coil will not be a plus anymore. It will be a negative. and at once it loses its charge. And the
Right.
other side will be a positive. And you see how the H3 diode is now facing that way to positive on A?
That's a nice
All
way of
right.
capturing it, eh? Yeah.
Yeah. Now people are flipping the batteries back and forth. This is automating it every. I guess
Yeah, you don't have to flip the battery. You flip the switch.
With this circuit, you just flip the. You need two inductors though. You need two drive coils, not one, to get this to work.
Interesting.
You need two drive coils. You
Yeah,
can't just.
hence the first diagram, right?
Well, this is the same diagram. Just
yeah,
half
but you
of it
took
is
one of the inductors
removed.
out. Yeah.
Yeah, let it go through. You'll see it. You'll see. Let it play. It'll bring back the rest of the schematic, and it'll show you the other coil will pop up. And yeah, man, this was stuck in my head for 2 years. Literally, I was losing my head. I had to get this figured out. There was an idea stuck in my head. I didn't know what it was, and it was based off the Bedini replication process. Brought this idea to me somehow, and 2 years later, I was like, this has to come out of my head. I have to figure out what is this? You know, what is this idea? And I had to sit down for 3 hours. About, you know,
I wonder if my
blank paper,
where your inductors are, because like you said, you have to have two coils for this. My system works a little bit differently. It creates spin without moving parts. I wonder if I used one of my inductors one way and the other, like my secondary the other way.
Yeah. That's just that counterclockwise, clockwise thing. I just put that in there and just for Pete's sake.
No. Yeah, I get that. You know what? I'm going to try this circuit on my system, and if it works, that's awesome. I'll do what I can to send you a coil for yourself for that.
I mean, technically speaking, if battery A is pulsing coil 1 for 180 degrees of one cycle, and then battery B is pulsing coil 2 for that other 180 degrees in the other direction, and you have a third coil picking up in the middle, or, you know, those two coils are wrapped around an inductor, and then you have a third one. Theoretically, you should be getting an alternating current, you know, from that.
Oh, I never thought of it that way.
I mean, that's what I'm thinking. North, south.
Yeah, you're right. You're right.
You know, when you build a three-phase motor, a generator, you have a coil, you have a round coil, and the magnets north and south have to land over the arms of the coil. So you got north and south over one coil, creating AC on a three-phase alternating generator. So in theory, this is the same thing, north-south, but DC pulses creating them instead of magnets passing over a coil. I'm sure this is one way of converting DC to AC. I know that the DC inverters, they just pulse DC from the 0 line with timing, you know, up to the 10-volt line to simulate an AC signal, you know, and then down back to the 0 line and below the 0 line to the negative 10 volts. And they just pulse that pattern, you know, in a sine wave. They pulse it. The voltage values from 0 to 10 positive, down to 0, down to 10 negative, back up to 0, back up to 10 positive. That's a DC inverter simulating an AC sine wave. Well, this is another way of doing it with pulses, but not exactly the same as, you know.
That's interesting. You might have something pretty huge there, you know.
It's a lot easier than doing it the digital way.
That's awesome. I'm going to try that circuit out. I will definitely let you know, Mike, if it works with my coil without moving parts. That's awesome. The way you explained it, the way I'm going to put that circuit together with it, that's great.
Can you guys hear me?
Yep.
Look. Yeah. Yeah, no, this circuit, I've never actually tested it yet. Just so you know.
Well, I'm going to test it this weekend or at least by Monday, Tuesday, and I will let you know by far.
If you got two identical coils.
That's what I like.
I do. I've built over
You should be.
175 different coils, like geometrical formed and all kinds. So I have some double.
I'm guessing you're going to have to find a way to make sure switch B is open before switch A closes.
What about a double pole, double throw SSR?
Yeah, that'll do it. That'll do it. I was going to do it with a. My method of doing this was to put two bifilers 90 degrees apart around a rotor that has two drive magnets 180 degrees apart. And if you want to add torque, you can add another two bifilers, making four in total, keeping them the two pairs 90 degrees apart, but each pair 45 degrees apart around the same rotor with four magnets 90 degrees apart. But to start, two magnets 180 degrees apart and two bifilers 90 degrees apart around the rotor, you will have the same triggering effect as the double pole, double throw relay. And only you'll also have the locomotion added to it, which might be even better if you want to tie a three-phase alternator into that, which is my ultimate goal when I get my lab reestablished.
Yeah,
that's
you know
what
what?
I'm going to do.
That's an interesting circuit, the way you explained it like that.
Gerald, my plan is to put the two 180 degree magnets on the circumference of one rotor, and to put a three-phase magnet array on the same rotor, on the face of the rotor, and then put a stator above that face to pick up the three-phase.
That's an interesting configuration. I can't wait to see that.
one rotor, one stator.
Yeah.
The rotor will be DC pulse driven through the circumference with two magnets on the 180 degrees, and the AC output will be on the face of that same rotor. Now you'll have a gap to put the two magnets. This is why I started with two, but you could do it with four. You'll have, because there's four gaps in the circumference where there are no magnets on the face, within a, I don't know how to say this, but on the three-phase system, if you have 12 lines in 30 degrees apart, that would give you 360 degrees. So, and if you put a north-south on 30 degrees, on 0 degrees you put a north, on 30 degrees you put a south, then you skip a magnet. There's nothing on that degree there, on that 30 degree. And that's where I would put the drive magnets on the circumference for the two drive magnets 180 degrees apart. I would put it right there in that gap, so you don't have too much interference on your three-phase magnet array from your drive magnet on the DC pulse side.
That's an interesting configuration. That might actually, wow. That's something that have to be tested, but yeah, I do. I totally do. If that could be accomplished, you have a generator in a generator. Well, you have a motor in a generator, actually.
DC pulse generator, DC pulse AC generator.
Yep, that's exactly what that would be.
Using the flyback. So you essentially, I wouldn't recommend drawing off those two batteries, because I don't know if the flyback is going to be capable of doing anything more than keeping the power that's in the battery to begin with.
Yeah, that's part of the run system. So where would you?
Right. I don't think I would draw off the batteries, because you might just lessen your flyback power. I don't think that the flyback is I've never built this, so hey, you might find that the flyback is providing enough power to not only keep the battery charged, but to also draw some off of it. In which point you don't have to go the locomotive way for AC.
I know what you mean. You've given me a lot to think about here. That's great.
Right. I mean, that's what I was thinking. If I draw off the battery, I might just stop the system. If it works, the flyback is successfully dumping back and forth between the two batteries and keeping them charged.
Yeah.
But what if you start draining off that charge? Then what? Is it that stops the whole process? Possibly. If that's the case, then you don't draw off the batteries. You just draw off the inductors. You use the inductor to spin, and there is no draw really, because the inductors are just releasing EMF. When you're pulsing the inductors and capturing the flyback of those inductors, you're not capturing the flux that those inductors created when they were charged. You're capturing the zero flux, flux. You're capturing the flyback.
Yeah.
Right. So you can harness the flux instead of not doing anything with it. You can go ahead and spin your wheel with it, and it has nothing to do with the flyback though. So how is it going to stop the flyback from successfully keeping your battery charged and keeping it going?
That's, you know what? That's an interesting circuit now that I look at that. That might actually be what I need to complete.
I had this circuit posted for a while. People have seen it. Not a lot of comments. I'm guessing nobody's seeing it. They're just seeing it. They're not really seeing it.
Well, I'll be honest with you. I drew it down. It's sitting on my pad of notes, and I was going to get back to it this week. Because I know that I look at it and I can see how that would work.
I didn't even see the Bedini circuit the whole time I was replicating. I just was doing it. Just do it. See, figure it out there.
You have an understanding of Bedini without actually understanding what Bedini was trying to do. I always call him Bendini. I don't know why I do that.
Bedini.
Yeah, it's Bedini.
John Bedini.
Yeah.
So Don Smith does the same thing, with the flyback. With his capacitors, he's using capacitors to switch. I think.
Who's that? I missed
Don Smith device.
Oh, Don Smith. Yeah. Really? He was capturing flyback?
I'm pretty sure he's using capacitors to switch them, not inductors. Because when a capacitor is fully charged, it acts like a short across the two terminals.
It does, and then when it drains,
it's effectively a switch once it's fully charged. It's effectively a closed circuit. It creates a closed circuit, a switch,
Huh.
So I'm thinking that's what he did with the flyback. That's how he was able to get away from transistors, because at the rate that he was switching was high frequency. There's no way you're going to keep those transistors going. They're going to blow. I'm sure he had that situation going on with transistors, and that's why I don't know if I never replicated the Don Smith, so I'm just guessing.
Yeah,
I don't know if he's got transistors in it or not. I don't think so. I think it's all capacitors and coils. And
I got a big data dump of Don Smith's stuff, but I haven't had time to replicate it. I've been doing so many other things.
Right. So, I'm figuring that he's just filling up capacitors at a voltage pressure ratio, which gives them a frequency. Once they charge at that voltage, they charge at a certain frequency based on the pressure of the voltage and the capacitance. So, and once they're fully charged and the capacitor dumps its charge, that effectively is your pulse, which can go into the coil at that point. That if he's got coils.
Yeah, that's the kind of principle I use on my bifilar. My bifilers are wound 180 degrees out of phase from each other, and that's how I capture my back EMF through, like I said, a diode and a capacitor. It fills up.
How do you do that?
What's that?
How do you do that? What do you mean 180 degrees? They're two wires together.
Well, my coils are. See, most people's understanding of bifilar is when you're, like, say, winding a solenoid, right? You're doing one coil and then you're doing another coil over top, right?
Or you can twist them together.
Or you could twist it together, right? Mine's completely different. Mine's a geometrical form, and I wind one sequence of numbers and then I wind another sequence of numbers 180 degrees out of phase. In that geometrical form, and by pulsing it like that, you'd be surprised how much geometrical forms matter when it comes to electrical engineering. People have
You
not.
know, I agree with that.
Yeah, they haven't done enough experimentation on them, I believe. We've always been using just solenoid coils and even just like transformers that I guess you could call them solenoids, but you know what? It's been so basic for the last 120 years. Nothing's changed. We need to look at open core coils and geometrical forms in order to, if you look at how energy flows, try and mimic that flow itself. That's what I was kind of trying to do in the beginning. And yeah, it's amazing how if you look at energy in a different way, like a ball of light, or sorry, maybe I should put it this way. Look at it as a series of line inductors that are formed into a geometrical shape. And every time you pulse, say like you pulse the coil, the very first sequence of that pulse is a north-south. And as it keeps going through the coil, it's another north-south and another north-south. And it follows that geometrical form into a spiral till the coil ends. But I also have another coil that's wrapped in between each line, like capacitor plates. That's the 180 degree out of phase secondary, my bifilar. I have to do a video.
Do you get the 180 degrees by going in reverse counterclockwise as opposed to clockwise, or are you getting it from the positioning in between the winding?
Both. I'm going clockwise and counterclockwise, and I'm getting it in between each line. The skin effect actually multiplies the overall power of the whole system. I like the skin effect. Most people, yeah, they try and cancel that out. The skin effect it creates spikes, and it's a problem in electrical engineering. Well, I want the skin effect. I use that.
It's not a problem if you got a battery or something you can throw it into.
True.
It's nothing but free energy in a sense.
I'm going to be doing detailed videos on how to wind my coils. There's a whole bunch of them. I've done about 15 so far on 15 different separate coils, but I still have a lot more to do. Like I said, I've built over 175 of them. Not all of them worked. There was some crash and burn, a little bit of smoke happening in certain ones, but yeah, I got to do some more in depth on how to.
And the next step also is the alloy of metal that you use to wind, and maybe adding some bismuth silver into the mix a little bit.
I always thought about using gold as a coil.
Yeah.
That's the dream. Well, the golden coil, right? That's the golden halo that is above those ancient angelic deities, right? Or that opens up that portal. It's always some giant golden portal or a giant golden crown on the royalty. Who knows?
I want to use
technology that is.
I want to use silver wire on my primary, and I want to use gold on the secondary. I just can't afford it.
How do you make an enamel coated piece of gold? And who's going to do that?
It may not be easy.
That's the material science that we're now developing through this electrolysis nano monoatomics that alchemy that I'm doing, as well as then adapting it into the 3D printing with the nano lattice structures, and the final topic of today's thing being the superconducting LK99, but just how it's material science advancing so much in these little nano freaking particles, and just organizing them in the right complex geometries gets you the superconductivity and I guess the universal energy hacks.
Well, when you think about sine waves that are coming from all over the place. They're usually in spiral, wave shape. So any conductor that you get lucky enough to actually match the same size of that wave, it should capture it.
I've got a small
dimensionally
coil.
speaking.
Yeah, I've got a small coil that geometrically that I built, and it levitates over a neodymium magnet, and it can hold 5 times its own weight. 12 volts, 1 amp.
You give it 12 volts and it floats over the magnet.
Yeah.
All right. Well,
Yeah,
while I have you, sorry to
12
interrupt,
volts or
because
pulse?
we have 9 minutes left before I have to end this stream because APEC is starting. And Mike, it's been an absolute pleasure having
I'm
you
hopping on APEC next session.
on with Mike Faraday Research and discussing where Mike with Faraday has done a lot of the Don Smith experiments and built with it, applied into these DC pulsing and this negative flux that you're understanding and engineering in here. We'll play your last couple of videos that are a couple minutes each here, and then I sadly have to end this, but we will coordinate and make sure that we get a longer full stream with yourself, Gerald, myself, Jeremiah, and Faraday Research going.
Yeah, we'll have to get into that.
Gerald, this video here is a way of controlling a spark gap at your timing, at your desired timing pulse.
I just put it up on my, I grabbed all those links and I've got them open right now. I'm just waiting to watch them.
So I'm thinking if you pass a magnet over the core, right?
Thought I'd bring this up to you guys.
Oh, there you go.
This is a spark gap system that operates off of magnetic fields that are induced inside of a core, an iron core. When the North Pole hits the iron core, a magnetic field will be induced on the other end of the core of a north field. If your spark gap is close enough, it's possible the voltage will jump across. And if you have your winding of your coil that is wrapped around that core welded to your core, when the spark gap positive voltage from the battery jumps across to the core, it will energize the coil. And assuming that this north field here, when it does pass this north magnet on a rotating rotor, when it passes this core, that's assuming that it works and it induces some kind of a flux field that then attracts the positive voltage to jump across the spark gap. I don't know what you would call this. I'm calling it a magnetic flux spark gap. All right, just an idea. Maybe someone will try to do it. I haven't built this. I probably will try to do this.
So this is perfect stuff for Falcon Space, Mark Sokol, as well as Jeremiah, Technicians, Exotic.
And it's unbuilt, and it's open source.
Just APEC in general community. A lot of them have the resources.
Go buy a dash cam. Get a smart rear view mirror.
Good ad, sorry. But they actually have the resources to test those and make those, and have the vacuum tubes and controlled conditions and all of it.
That's right. APEC has what was his name? Josh, I think his name. He has a lab and doing all kinds of experiments with
many of them do. Many of them have all
T. Townsend Brown, the asymmetric capacitors.
Right. We need to do a full series on T. Townsend Brown as well.
Earth is an asymmetrical capacitor. If you could tap it, you got free energy, essentially.
That's what the ancients do, or did, to still do. Some of the ancient sites, or the ancient antiquitech architecture. The electroculture essentially is doing the same.
Maybe Maybe those pyramids are probably part of that, the whole
100%.
operation of that.
Oh, they are definitely
Being asymmetric to the Earth, I guess.
Well, you can pull voltage out of the air if you ground it. So it's like you're completing the circuit, right? And every 3 feet is 100 volts potential. There isn't a lot of current, but if you could manage to get high enough, like Tesla did, and you were able to capture that voltage, send it down into the ground, into a massive inductor, just the very flow of it itself would create current. And then you know how inductors work. You're talking flyback, you're talking boost converter, the whole 9 yards. And essentially you could
you can convert the high voltage down. You could drop the high voltage and convert all that voltage that you lost on the high voltage side can be converted to amps.
Yep.
With low voltage. So that's the whole idea. You get like all them thousands of volts with no amps. We bring down 1,000 volts to 10 volts, and now you have 10 volts with some amps.
Well, you know how Nikola Tesla's patent on the Tesla coil to create sparks? I think he inverted it. The guy was a genius. If you flip it inside out, it's like an antenna array, captures the voltage, sends it down the high voltage coil, steps it down through the primary, so to speak, goes through the spark gap, and then goes to a step-down transformer to the power you want to use. I think he reversed it. And
possibly. He just never told nobody.
Yeah. And he figured eventually civilization will catch up. Somebody will figure it out and pass it on.
And we finally,
you're saying instead of using the primary to give that power to then make the secondary put out high voltage sparks, he was allowing the secondary to receive high voltage, and this primary was then putting out power.
Absolutely. The primary was actually stepping it down, creating more current, sending it through a spark gap, which allowed him to define the frequency going into the step-down transformer at the end. The guy was a genius.
Yeah, Tesla. You know what else he did that was ingenious? I replicated his 3-phase system using the 12 lines 30 degrees apart in a circle and 8 magnets and 3 coils. And I noticed 100, when you do it that way, you have 120 degrees for each of the 3 coils. Means 3 times 120 is what?
3. Yeah, it's 360. It's
1 cycle.
Yeah.
And then I'm thinking, what is that 120 degree angle doing? Is that 120 degree angle creating 120 volts through the angle?
Interesting.
And I'm like, wow, Tesla really had this figured out, man.
He knew the power
even down to the angle, or the angle of separation between the coils and the magnets.
He was a genius.
So if you get that 360 degrees turning 60 times a second, you will have 60 hertz at 120 volts. But I don't know what happens if you have it turning 1 time a second. You're probably not going to get 120 volts, but you'll get some divisible number less of that 120. More than likely, it'll be an exact. What do you divide 160, 30, 15? You'll probably get like 1 turn will give you like 15 volts or 7.5. When you multiply that up, it equals 120 degrees.
Yeah, you're not wrong. I never thought of it that way, but that's interesting. I got a new experiment to try now.
There's something going on there with the
several.
Yeah,
the magnets and the coils regarding the 3-phase system that Tesla designed. And from what I understand, he never intended that to be a motor or a locomotive device of any kind. It would just guzzle energy if you did that, and it was intended to be strictly a generator because it really puts out a lot of energy. So that's why the 3-phase alternating generator is still the best way to make power today. Nobody has beat it.
Well, APEC is going to be starting soon, so I'm sure Bernie wants to cut this out.
It's all good. I'm actually
I'll
in
see
the
you guys
back
there,
room
man.
right now, and you guys are talking like absolute gold. And this is genius discussion that I'm going to be rewatching.
I'll be on APEC with you guys, so
and
lots of
editing.
fun.
So keep her going as long as until they hit the start, I guess. Or keep, it's all good. When you're on a roll, we're on a roll, and we're on a toroidal roll right now. So let's finish it off with a clip for Year of the Coil, because that's what this should be.
You were talking about three-phase.
Bernie, so you can go ahead, Joe.
And the alternator system that he created. I have a generator that has 3 alternators run by a permanent magnet motor, and I'm getting crazy power. Not as much as I'd like, but
a permanent magnet motor is a DC motor.
Yep, I'm using DC to get AC.
Right.
Yeah.
Which is how, if you ever see those guys doing those 2 motors connected and they're running themselves, the only way you're going to get that to work is if you're using a smaller DC motor pushing a larger AC generator.
But you have to have the torque in order to do it, and you have to be able to control the input on the AC so that you can wind up your speed first.
You mean the output on the AC?
Yes, sorry, the output on the AC, in order to wind it up first and then add your
right
input power to get.
You got to get it started first. You got to get up to RPM. You got to get it started, of course. You got to get up to RPMs to get that right amount of amps to keep it going, basically.
Yeah, otherwise the torque destroys it right off the hop. But if you can get it spun up first and then add your power for your output, and that torque's applied, it just keeps going. It's awesome. Yeah. Plans are free. I give it away to everybody. So
I'm stoked on ElectroCulture and agricultural alchemy, combining the monoatomic colloidal waters with ElectroCulture, and then adapting some sort of atmospheric harnessing and grounding, and also like using trees as antennas with like apparently wrapping a couple of solenoid wires around your big trees, and you got yourself huge antennas to collect.
So Bernie, your monatomic elements, I believe, are a very key component to I study the human body, and I study the energy points of the body, and I've studied acupuncture, and I've studied the chakras and how it's all interconnected. And I believe that monatomic elements are the nutrient energy filled component that allows your body to hold on to a higher vibration. But you need to, it's not just the monatomic elements, it's the monatomic elements and you having your body stand within a resonant field of excess energy in order to activate those elements in your body.
It wouldn't surprise me at all if these elements, these monatomic elements, are not just simply generated through spin.
Yeah, they're high. I believe they're high spin rate nutrients that are meant.
That's literally what's part of like David Hudson's original patent is calling them like high spin elements.
Yeah,
that's his name, David Hudson, right? Or Hudson.
Yeah, I don't think it was for creating white gold. I think the whole purpose behind white gold, if you look at the history behind alchemy, it brings you all the way back to Moses in the Old Testament. And I believe that manna that was talked about, that was fed to the Israelites for 40 years in the desert, that's the exact same white powder that the alchemists talk about. It's manna. It's high spin rate nutrients for the human body in order for it to hold a higher vibration.
Bernie, have you ever made any GANs? You ever heard of GANs?
Oh yeah, GANs is the exact same stuff. GANs is how I learned it. Gas, atom, nano, solid state is Keshe's acronym. It's essentially just a different acronym out to ORMUS, which is monoatomics. And yeah, there's a lot. Keshe is very, very highly intelligent in that whole field of it, and what's basically the inspiration behind a lot of my agricultural alchemy work as well. And they've done like 10 years of agricultural experiments with this, applying these different things to the plants and getting giant yields, and it's pretty cool.
You ever make zinc?
Yeah, I got looking at it right.
Do you eat it? Do you consume it, the zinc?
I just the water I consume. I don't really. I gotta start eating more of the Monatomics, and
Are you using
we'll see
using
if
some sodium hydroxide, right?
comes, or start getting telepathic things. I don't know. When I've absorbed it through my hands, all of a sudden, like, I get temporarily, like, when I touch things, like little lightning bolt things come out of my fingers, and I was like, yeah, and it happens every time, and I'm like, do I want to eat this and like turn into this lightning thing?
What was that, the zinc, or what were you eating? The zinc?
The copper. Well,
don't eat the copper. Oh my god.
Oh god, no! I'm just saying when I've absorbed it through my fingertips.
Oh, your fingers. Okay, yeah, that's
no, God, no, not consuming any of that. Jeez, that's what I'm saying. Like, just from touching it, absorbing it through the fingertips.
Are you activating your water with lye solution, or are you just using straight?
No, God, no. I don't know the lye. Well, I think that could be a very powerful aspect to it, but I have yet to like understand that one, so I don't mess with it because I'm just with straight water right now. But I think that is how you control the pH, which is another crucial step to structuring water, and something I gotta look into further. That said, APEC has now been live for 5 minutes, so we should end this and get over there and continue.
Thanks
this.
See you guys over there.
All right.
See you guys.
Much love.
I'll see you on APEC.
Have a good one.
And
you crazy mother. Yeah.
It's just Bernie.
Bernie just like last week, huh?